here we're going to be looking at multiplying and dividing fractions. Now, one simple trick, you can get the exact same result. So we've got a few examples here that we're going to work through. The first, we'll start with multiplying. Now, what I like to do with the multiplying fractions is get rid of that multiply symbol and write it up the top and at the bottom. Okay? Because all you do when you multiply fractions is you multiply the top and then you multiply the bottom. So here it's 1 times 1 equals 1. 2 times 2 equals 4. So a half times a half equals a quarter. Now we're going to do the exact same thing for the next problem. Delete that multiplication symbol, write it up the top, write it down the bottom, and then carry on. So we're going to have 7 times 3 over 10 times 10. Okay, 7 times 3 is 21. 10 times 10 is 100. Now moving on to our last set of fractions. So again we're going to delete that multiplication in the middle, write it up the top and write it down the bottom. Once you've done that, we have 3 times 2 up the top over 5 times 3. Now all we do is go through and do those calculations. So 3 times 2 is 6 over 5 times 3 is 15. Now there is a slightly easier way to do that, so I'm going to rewrite that multiplication. If you see 3 times 2 over 5 times 3, there's a 3 in both of those sums, so you can cancel those and your fraction simply becomes 2 over 5. And you might be thinking, but that's different from the 6 over 15. But if you simplify the 6 over 15 to its simplest form, there's a factor of 3 in both 6 and 15. So when you divide 6 by 3, you get 2. And when you divide 15 by 3, you get 5. So 6 over 15 and 2 over 5 are actually equivalent fractions. Now we're going to move on to how to divide fractions. Okay, with this we're going to show how to divide fractions just with a simple trick. So first you flip the function at the back and then you just multiply like normal. So here we have 2 over 9 divided by 3 over 4. So right, 2 over 9, then we flip that second fraction to be 4 over 3, and then we just multiply like normal. So we have 2 times 4 over 9 times 3, which equals 8 over 27. Yeah, and we can leave it at that. Now we're going to do 3 more examples, and we'll go. So the next one, 6 over 7. Then we divide, so we're going to flip that second fraction. So 6 over 7 times by 4 over 3 equals 6 times 4 over 7 times 3, or which equals 24 over 21. And that gives us an improper fraction, so we can change that to 1 and 3 over 21. And again, that can further be simplified to 1 and 1/7. Okay, because they had a common factor of 7. Now we'll do 2 more examples. This one has a shared denominator, so we're going to 1/3 then multiplied by that flipped fraction. So 1/3 times 3 over 2 equals 1 times 3 over 3 times 2, which equals 3 over 6, and they have a share a factor of 3, so 3 divided 3 equals 1, 6 divided 3 equals 2. Now our last one down the bottom is a special case, but we can still do it. So 1/2 times by 2 over 1 equals 1 times 2 over 2 times 1, which equals 2 over 2, which equals 1. Now this, what you see at those fractions, that's actually called the reciprocal of a function. So if you have 1 over 2 times 2 over 1, that'll always equal 1. However, we'll cover what the reciprocal is and what it does in the next few videos. So until then, goodbye.